Okay. I think we're live. Let me just check a few things here. Trying to you can hear Panther. Yeah, it looks like we're going. Okay. Hey everybody, welcome back to another Deep Astronomy live stream disaster. My name's Tony Darnell. I'm from deepastronomy.com, and we are going today to talk about a mission that has kind of slipped underneath my radar. I didn't know anything about this, but it's the NASA's IXPE mission, which stands for let me get my thing up here. The Imaging X-ray Polarimetry Explorer. I didn't know about this. So, because I didn't know about this, I was pretty sure you didn't know about this. So, I want to talk about this a little bit because it's an NASA mission that is cool, and I wanted to learn a little bit more about this. So, one of the best ways that I learn things is I try and present them to other people so they can learn about them too. That's how I learn. I learn by teaching, which is the tried and true very venerable way of learning things as promoted by the great Richard Feynman. So that was one way it was his solution to a way to learn anything in the universe is to try and teach it to someone else. And so that's what I do, and that's why one of the big reasons why I do these streams. So as you guys know, I was out last week because of a trip to London. I braved the Omicron variant and made it to London visiting family for the first time in 2 years. And we had a nice visit. I was just telling Peter about it. We're actually from the Northeast. My wife's family's from the Northeast, but we didn't get that far just because it was too much travel involved for a small child. So we just hung out in London. And it turns out I went, as one of the days I was there, I went to the Maritime Museum, which has been one of the places I've always wanted to go. And I just so happens, coincidentally, they had an astrophotography exhibit there of winners of an astrophotography contest or I guess it was a contest, some kind of awards they won. Anyway, it was really cool. We got to see a lot of really great astro photographs from people around the world. I didn't really recognize any names in that have won that had won, but except for Andrew McCarthy, I recognized his name. But there was lots of people from Norway who did a lot of really great images of Aurora, which is one of the categories. So anyway, that was a lot of fun. I also got to see Lord Viscount Nelson, Horatio Viscount Nelson's um, cloak or uniform where he was actually shot in the left shoulder. And that was kind of cool too. I don't know. I'm an old sea dog, so I like that stuff. By the way, I want you guys to all start calling me Viscount. That's a great name. I love that name. Horatio Viscount Nelson. What was his name? Was it? I know Viscount's in there anyway. All right. So that was a lot of fun. And I would invite you all. So I'm streaming on all of the things, except for LinkedIn, which I'm a little bit afraid to start doing there, but I will eventually. And so please feel free to comment on all the things. I can do stuff like this with Raj Luthra. Raj, I know you were also in London and I wanted to get a chance to see you. I just didn't have time. So that's why I didn't reach out. I knew it would be crazy. But one day when I get back to London, I'll be sure to look you up. So sorry I couldn't make it on this particular trip, but it was very, very busy. So anyway, I can do that and a bunch of other things with this stream and a couple of news item. Hey, John, that's John Suffle. I'm also from the UK. A lot of UK people here, and of course, Captain Quinn, my friend from the Northeast. Um, so it's good to see you guys. My good friend Stream Elements. Oh wait, I'm just kidding. Stream Elements isn't my friend. All right. So let's see. Official Mastari. This is an interesting one. As far as I know, the IXPE's gas pixel detector is assembled at my university here in Finland. That's very cool. I will talk about that just a little bit when I get going with my slides. It's also, the spacecraft was built by Northrop. What am I saying? I've got JWST on the mind, as I'm sure we all do. It was built by Ball Aerospace in Boulder, and it's being operated by my alma mater's University of Colorado LASP, which is the Laboratory for Astrophysics and Space Physics, I think. astronomy and space physics. They're operating the spacecraft as well. So yeah, we'll talk about that gas pixel detector and some other things as well, because I didn't know much about it. So let's do a little bit of news first before we get going, because there's news, everyone. Let's talk about Hubble first. It turns out Hubble is now back into full science operations. You may remember that back in early November, it went offline. There was some synchronization issues with some of the logging and stuff that was going on with the software. They, I think, rebooted the whole thing, which was kind of iffy, and went to the backup electronics package, which they've never used. And then they one by one started powering on the science instruments, and they finished with the STIS spectrograph, the Space Telescope Imaging Spectrograph, on Monday. Just last Monday, they turned it back on. So Hubble is back. 31 years. That thing has been up there doing stuff. Now, it's been repaired 5 times, but nonetheless, pretty cool track record. It has changed our view of the universe forever, and it is to be eclipsed only by what's coming up next, which you guys know is the James Webb Space Telescope, JWST, Just Wait Space Telescope, the Webb Space Telescope, the Just Waiting Space Telescope. What other things have they come up with for this? Anyway, last Saturday, December 11th, NASA says they put the telescope back on top. It's on top of the rocket. It's been fueled up. It's got all of its hydrogen and other fuels that it needs to do its mission. And it's sitting on top of the Ariane 5 right now for launch next week. So that's huge news. Here's pictures of it being put up there. And there it is on its folded configuration, getting ready to go into the rocket itself. So it's on top of its rocket. It's almost ready to go. So in anticipation of this, if you've been following this for as long as I have, I know that you're a little bit nervous right now. So here's what I'm doing. Next week, on Tuesday, the day before the launch, I'm having a pre-launch therapy stream where we're going to get together and we're just going to take a deep breath. We're going to center ourselves and get ready for the most sphincter tightening induced moment of our lives, and get ready for the launch, which I will also stream the following morning if it goes. December 22nd, a week from tomorrow. 6:30, I think, or so, 6:47, maybe it's 6 or 7:40, I forget now. It's in the event that I posted. I will be live streaming just a little bit before the launch goes off, and we're going to watch it together. Now, I know you guys will probably have 8 different tabs open of different live streams, but keep mine up just for fun. Check in with me, see how I'm doing, and while you're popping around to all the other live streams, chat with me. Let's do this together. What I'm going to do is capture. I'm going to capture NASA's main stream. I already have it set up and ready to go. Here is their official broadcast. I'm going to capture this and just watch this along with you guys. And so we will try this out together. So that's what I'm going to do. And I know you guys, if you're anything like me, I know what you'll do. You'll have like 5 or 6 different tabs open of different streams. You'll probably be on Twitch. All the different people you follow will be doing this at some level. So I'll be out here. I might not be saying anything. I might just be going, which is why I need the therapy stream the day before, just to kind of center myself and get ready. Anyway, on Tuesday, what we'll do is we'll talk about the telescope itself. I'll go over some of the instrumentation. We'll watch a few, attaboy videos about it. I'll show you my video that I made back in 2013 on JWST that I made while I was at the Institute. And at the time, it got a lot of good reviews from the Space Telescope Science Institute. Of course, they've since come up with many, many more videos since that, much better quality. But that was my attempt at doing it. And so I'll show those kinds, and we'll just chat and hang out. So show up, and let's get centered, and let's meditate. We'll meditate the way science nerds meditate. We will reason through all of the reasons that this thing's going to go. I'm also going to go over the main things to watch for throughout the main milestones of the mission, because there's going to be a lot. The launch is one, deployment's another, getting to L2 is another. So many things have to go right for this thing, or it's just an utter failure, right? If it doesn't get to L2, the mission's scrapped. It won't work because it's been designed to work just there. So there's that. So join me next Tuesday, and we will therapize each other, and then we will come out on the launch the following morning, and hopefully it'll be going well. But we'll know at least if the launch happened by then. So a little bit note on the rest of this week. I'd hope to stream tomorrow, but I can't stream tomorrow because I am recording a Space Junk podcast episode. I would normally nominally stream on Thursdays. I can't do this Thursday because my wife's coming in on the airport, so I have to go pick her up. And so the next time I'll have a chance to stream is Tuesday when I do the therapy stream. And then after the launch, I don't know. Christmas is coming up, lots of holiday stuff. So I'll let you know on Wednesday whether or not we'll have any more streams until the new year. So here we go. All right. Let me find my slides. Let's get started. Where are we? Slide show. Okay. Today, what I want to talk about is the imaging X-ray something Explorer. I already forgot the IXPE thing because I just didn't know about this. It just really caught me by surprise. So what does this mission do? Well, let's take a look. Oops. Let's take a look at the basics. This is it is an Explorer class mission. It costs about $188 million. That's a range of costs for missions. NASA hasn't broken up into different classifications. This one's called Explorer. It's going to go into a 540-kilometer circular orbit around the Earth that will go over the equator. That's what it's going to be. It's slated to last for 2 years, and it was launched last December 9th. And as I mentioned earlier, Ball Aerospace built it, and it's being operated out of CU LASP, which is the Laboratory for Astronomy and Space Physics, and in Boulder, Colorado. And it is currently operating nominally. It's as its launch is getting geared up, and they're deploying it now. Okay, some of the things that it's going to do science-wise. It's going to look at polarized X-rays. That's the important word, polarized. Remember that. We're going to come back to it. And it's going to look at polarized X-rays from neutron stars, pulsar winds, stellar and supermassive black holes. And it's going to look at magnetic field configurations in magnetars. It's going to get the magnetic field strength of those things, as well as it's going to determine the geometry and emission of the emission mechanism of active galactic nuclei. Now, the coolest thing about this mission is that it's going to be not just looking at X-rays, but polarized X-rays. And the reason for this is important. But before I go into that, I need to tell you a little bit about what polarized light is. I had to change my background because the image I got was transparent, and I needed a white background. So polarized light is a special kind of light that comes out of that is emitted in all wavelengths. You can have polarized light in radio. You can have polarized light in visible as well as infrared, and all light can be polarized. And there's lots of ways that you can do it. But what polarization is an indication of the direction of the magnetic field. Now, an unpolarized light. I'm sorry, the electromagnetic field, not the magnetic field. That's both the electric and the magnetic portion of the wave. In unpolarized light over here, this electric component of the E&M wave is all over the place, right? You see it, it's vibrating in all different directions as it's traveled. But polarized light selects only one of those waveforms that's in a specific direction, and that's called polarized light. Now, in this example, it's being polarized by using a filter where it blocks out all the other orientations except the one that's up and down. It blocks out all other waves, electromagnetic waves, except the one that's parallel with the polarizer. That's one way you can make polarized light, but you can actually make it in a lot of different ways. Whenever you look at a reflection anywhere, whether it's light coming from the sun reflecting off of a pond and into your eye, that light that's reflected off of the pond is polarized. It's scattered, it's just reflection off of that surface. And that's why you often see fishermen and boaters and all of this kind of stuff wearing polarized sunglasses, because it cuts down on the glare of the reflections from that surface. Sunglasses aren't perfect polarizers, so some gets through, but it does reduce the glare quite a bit and allows you to see just a few feet below the surface on a bright, clear day. So that's one way that's another way you can polarize light. So sending it through a filter is one, reflection is another, and another way to polarize light is by scattering it. Whenever light is scattered off of particles or other things in the atmosphere, for example, the blue light in the atmosphere, a great portion of that is polarized, and that's the part that is of interest here in this mission. Scattered light that is will be polarized by things like electrons, high energy electrons in dust clouds, things like that. And so, as you can see in these bullet points here, you can polarize light by scattering, which happens in nebulae, and relativistic electrons bent into a powerful magnetic field also emit polarized light when they're accelerated. That's another way you can do it, and that's an important process called synchrotron radiation, which is another thing that IXPE is going to be looking at. So the things of interest here are the scattering polarized light by nebulae and the accelerated the magnetic or the light that's given off by electrons as they are accelerated through a magnetic field through synchrotron radiation is the other. Okay, a little bit more. The reason this matters is that if you can see polarized light, then you can infer its magnetic field properties. And if you know that an object has a magnetic field, for example, a pulsar, then the polarization can tell us which way the magnetic field is pointing, because it will follow along in a proportional way to the magnetic field of the object that's doing the polarizing. Synchrotron radiation, bending electrons, accelerating them, giving off radiation in a polarized manner, lets you determine the direction of that magnetic field. And that polarization that you see is also related to its magnetic field strength in something called the Faraday effect. And you can use models that are out there about these pulsars and active galactic nuclei, things like that, to know what you would expect to see from IXPE, and then the observations from IXPE will either confirm or not or deny those models. So that's what IXPE is all about. Where right now we're trying to get observations that will confirm a lot of the models of things like magnetars, pulsars, supermassive black holes, all these things that are accelerating high energy electrons and giving off X-rays. Those polarized X-rays can tell us a lot about the magnetic field properties of all these different things. And that is what IXPE is going to be looking at. So, and there will be cameras because there's always a camera. So here is a simulated image of what IXPE is going to be looking at. It'll see the brightest sources, because this isn't a big telescope. It's going to be seeing the brightest sources that include things like active galactic nuclei, pulsar wind nebulae, and shell-type supernova remnants. That's what it's going to primarily look at. And an example of that is right there. I don't know if you can see it very well, but there's little indicators of polarization here that you'll be able to see with a map. These are called polarization maps. that will show the not only the brightness in X-rays but also um, the polarization. So that's what it's hoping to see. Here's how it's going to see it, and this is where those gas pixel detectors come in that we were just talking about. It's going to so there will be 3 identical X-ray telescopes, and X-ray telescopes are very special beasts because, as you can imagine, reflecting X-rays is not an easy thing to do. Focusing X-rays is not something that is all that easy. So there's a lot of really special optical systems in there that have nothing to do with what you're used to with visible light or infrared light, even or even radio for that matter, because all of those things can be reflected, but it's very hard to reflect an X-ray beam, or at least focus one. So there'll be 3 telescopes on board the spacecraft. Each one will have these gas pixel detectors on it, and what'll happen is X-rays will go into the gas that's in there and create photoelectrons that are preferentially emitted in the polarized direction. So that's how you're going to tell a a a pixel will go off when a polarized photon goes into it in a certain direction that it's used to seeing, and it will glow and turn on that pixel. And then there's also going to be a start point and an end point. You can see here the initial absorption goes, there's a track that goes through here. There's an absorption that goes in there, and then it'll start. There's a start point and then an end point down here at the bottom. And that track that it makes between the start point and the end point, there's gas in here, in between this lower level down here. I didn't get a chance to look up what kind of gas it was, but that track will give you how much that light has been polarized, and it will give you the angle, the position angle of the X-ray. In other words, the polarization angle. And it is from that all of the science is being done. This is the first detector of its kind. This is not what Chandra uses. This is something that is designed specifically for looking at polarized X-rays. Chandra just looks at all X-rays. And this one is designed to look at specific, be able to tune it so that you can see specific polarizations of those X-rays, so that you can get these magnetic field maps from the polarization. This is one of the things. It's not unlike transit method for detecting exoplanets. It's an indirect method that you use to infer the existence of something else. So when you look at polarized, let me finish the analogy. So when you look at a dip in brightness of a star, you're inferring the existence of a planet that's doing the blocking of that light. You're not seeing the planet directly, you're seeing the decrease in brightness directly. But you're inferring from that decrease in brightness a model that says, look, what would this thing decrease? What would the decrease look like if a planet were moving in front of it? Now, it's a very simplistic analogy, but here we're saying, I've just measured a polarized beam of X-rays. And I'm inferring from that polarized beam, the fact that I've seen this polarized beam of light means that there's a magnetic field that was inducing this polarization, whether it's through synchrotron radiation or from scattering. And from my models, I'm going to say, okay, if I see this particular track of polarized light, X-ray, what would the magnetic field be like? And there's well-known correlations between polarization and magnetic field strength and direction. And then you can make these maps from that show you these magnetar, for example, magnetic fields, their strengths, their directions, and their magnet, or the strengths and their directions. Magnitude's kind of the same thing. So that's how this thing works. It's a very interesting detector that I've not seen anything else like, but it measures a track through a gas, and that track is preferentially weighted towards a specific polarization type. That's how it's going to do it. Okay. Oh, I already did the image. And so I think that's it. That's all I have. All right. So that's IXPE. And I am, like I said, I was not aware of this mission until after it launched. I'm like, what launched? So I've kind of gotten out of the loop. I guess I've not been at the Institute. So, and I've, shout out to Alberto Conti, who works at Ball Aerospace. I was following his Twitter feed. That's how I actually found out about it. So Alberto Conti was really is working at the company that that launched this, and I haven't seen or heard from Alberto in a long time. But shout out to him and congratulations on Ball Aerospace for getting this thing built and launched. It'll be up there for 2 years, looking at all these different things, giving us insights into the X-ray universe, which we desperately need because Chandra has also been up there for close to 30 years now, not quite as long as Hubble, 25 some odd years. I think Chandra's been up there. It's one of the great observatories, and it is a little bit long in the tooth. So we need to get up there with the latest decadal survey. There's been a lot of acknowledgement that we need another X-ray telescope. Lynx was supposed to go up and do some of this stuff, but I don't think that's going to get built now. So the X-ray universe can only be studied from space. Can't be done here on the ground. So it's got to be a priority. And of course, IXPE is one of those things that is doing it. Polarized X-rays. It's amazing to me that we can do this because it's hard enough, as I pointed out, focusing X-rays at all to any kind of image. Chandra does it using these concentric tubes that are very, very long. And X-ray telescopes tend to be very, very long because they reflect X-rays at a glancing angle. They can reflect an X-ray, but only a highly incident X-rays, and then they can only do it a little bit. So it's pretty impressive. Okay, so let me look. So if you want to, that's my little spiel for today. If you want to join me, you want to chat, Peter's already here. You can get on the live stream voice channel and ask some questions, and I'll put you through the stream if you want. Otherwise, I'll just look at your chats here. Let me do a couple here. Here's one from Mike. I wonder if it'll be able to see other stars' heliospheres. I don't think it's going to be big enough for that. Remember, these telescopes that it has are pretty small, and I don't know the diameter of those objectives, but it's going to only look at the brightest X-ray sources. Like I said, active galactic nuclei, supermassive black holes, things that are very, very bright in X-rays, because this is not a physically large telescope. So, so I doubt it. I doubt it'll see those. And heliospheres, if you think about our own sun, for example, our heliosphere is pretty massive. It goes way out past the Oort cloud, and the charged particles that make it out that far that would interact with those magnetic fields to begin with are pretty faint, and so I don't even think we could see it through X-ray telescopes here on Earth, if at all. So X-rays probably wouldn't be the best way to see a heliosphere anyway. You'd need other charged particles to do that with. So, okay, hang on just a sec. I got to put you on the stream. All right, go ahead. Now you're in. So you have.
Hello, I do have the size right here.
Of the size of the this is Peter, by the way, everybody. The size of the objectives.
Yep.
All right, what do you
got? It's 1.1 meters in diameter.
Each one?
And 5 meters tall.
Oh.
Fully extended is 2.1 meters. That's 8 foot.
What do you mean? What do you mean fully extended? Are you looking at
fully deployed?
No, I want the objective diameter. What's the objective diameter?
Oh.
Yeah, I think you're giving me the dimensions of the telescope. That seems huge. A 1 meter diameter OTAs would be really big.
Let's have a look.
All right. Oh, okay. Galaxia, while you're doing that, I'm gonna read this from Galaxia. There's been few news about this mission on YouTube. At least NASA uploaded videos now that it's launching. Yeah, I know, right? I mean, did you know about this before it happened? Because I missed it. I hadn't heard about it. Scott Kayla's is commenting: magnetic field map, North and South Pole inference orbit for switching magnetic reference. Okay, I don't know what that is in reference to. magnetic field map is north
The
and south.
mission objective diameter.
What is it?
The mission objective diameter, do you mean? Or the actual size of the machine?
What does it say it is?
Because
1 meter for each of those?
yeah, about 1 meter diameter. 1.1.
Okay. Still, this is bigger than I thought. Okay.
Yeah.
J Buck says it looks like some kind of space guitar. That's very true. Disillusioned, welcome back, and I'm glad to be back. So I missed not having the weekly stream. Sorry about that, but I am back. Next week we're going to be consoling each other, getting ready for this launch. So join us on Tuesday as well. I'll be ready with that.
Yeah,
see.
I'll have some book spares or what you Americans call mimosas in for Christmas. So I might have a bottle of that handy.
Yes, definitely.
Depending on the time.
Yeah, Dustin bought me a really rare bottle of Ardbeg a while back. If this thing launches, I think I'll crack it open for that, and if it goes off without a hitch. Otherwise, I'll drink the whole bottle in desperation if it doesn't. So either way, it's going down.
Going down.
Oh, okay. So this is from you, Captain Quinn. I got polarized sun snow shades that are great in the summer too for looking at monitors. Yes.
Yeah.
And Scott, I think is clarifying north to south orbit across equator, register polarized light waves of northern lights. Yeah, but this, I think you're talking about aurora in this case, and that is a similar process. So the particles that are being accelerated, the charged particles, the electrons that are coming in from the sun that are accelerated by the Earth's magnetic field, do give off light in the aurora as they're being accelerated, and that light is polarized. So I think that's what you're saying. So and the way you could test this is just take a pair of polarized sunglasses. The moon, by the way, the light from the moon is polarized because it is reflected light off of the sun. So if you take a pair of polarized sunglasses out one night and just kind of turn the lens around, you will see the moon get bright and dim, depending on the angle of rotation, because of the polarized light that's coming off of the moon. In fact, moon filters are basically polarizers. If you have a telescope with a moon filter that you screw onto a eyepiece or whatever it is, or insert in the path of the eyepiece, then that is the same thing. It just cuts down on the amount of light, lets you see a full moon, for example, in a telescope that would otherwise blind you. Those are polarizers also.
Yeah, and what that means in layman's terms is you can get rid of like glariness and actually see some of the features on the moon better.
A little bit more contrast.
Yeah.
Okay, so here we go. I know, right? The JWC launch is so exciting. I don't know if I dare watch it. Well, we all have to. We have to watch it. We have to watch it like this, right? We just have to go, and we'll peer out, and we'll kind of do this, right? And then we'll do this.
Yeah,
that's about how I'm gonna be. I mean,
our peripheral vision.
So I don't know,
man. Just out the side of your eye, as if it's just about there.
Thank you, Galaxy. I only have one app open, and that's mine. Thank you very much. But I understand. There's a lot of people going to be streaming, and a lot of people follow a lot of people. So by all means, I know it's feel free to watch us. Just so you're going to be. I see, and so Peter's going to be watching Everyday Astronaut. That's what he's going to be.
Well, he's got the best speed, I would think, apart from NASA. So
it'll be the best, will it? Okay, I won't take that personally. Don't worry.
Maybe you can piggyback it.
Yeah. So how it might be possible to detect heliospheres. I had no idea. Yeah, I think the problem there, Mike, is just going to be you've got so few electrons that are following out that far out from the sun. It's happening. There is synchrotron radiation going on out there. It's just going to be so faint that I don't think this telescope or any others is really going to be able to see it. I mean, the heliosphere interactions of the sun are going to be pretty faint, even pretty close to the sun. So, I don't know.
Mm-hmm.
Uh,
But if you want an interactive stream, a proper interactive stream without too many people coming in and you're having to pay super back chats to get seen, come here.
Right, because there
Yeah.
won't there will it won't be standing room only here. There'll be plenty of room. So please come by.
Yeah.
You go to these other big huge guys, and yeah, you have to super chat to be seen.
Yeah.
Here, I will look at you. I'm gonna have, what do I have? I got 30 people watching on YouTube, another 10 or 20 watching on Twitch, and then somebody else and the other platforms. So it'll be plenty of room, plenty of
Yeah.
room to interact and talk and to get excited together. So definitely stop by.
Which
And
is why when I'm looking for a stream to watch a launch or something like that, I always, it's either the NASA one where there isn't really a chat room,
yeah,
because
they
I
turn
just
off
hate it
chats. I
because it's,
noticed they turn off
that
chat.
just gets flat earthers in. Or somebody, that isn't so popular, like Mike of Origin. He does very good videos. Yourself, Tony, well, I've already mentioned you. Christian, he doesn't get many views. Launchpad Astronomy.
Oh, right, Launchpad. Yeah,
You
Christian.
know,
Yeah, he'll probably do
people
the stream
like
too.
ESJ and Space Googleplex and things get thousands as well.
Mm-hmm. Yeah.
So, you want somewhere where you can get questions answered, or if you're not really bothered about that, just go to a NASA site.
They're going to have the official version. And they're going to have all the experts there too, right? They're going to have Thomas Serbukin. They'll probably have Amber Strawn.
Yes.
Amber Strawn was on 60 Minutes on Sunday. She's the one of the project scientists there. I worked with her briefly when I was there on Hubble. But she's like the JWST project communicator person. I don't know. Anyway, she's always out there in the forward facing part of it. Jason Callery used to be a big part of JWST, but I think he's moved on to Johns Hopkins APL. So I'm not sure. He's involved in the project, I think, but not like he was. He was one of the project scientists. And of course, Massimo Stiavelli is going to be the project director at the Institute. He's big. So all these people are going to be, on the NASA stream. So you definitely want to watch it because I'm not going to get those people. They're not going to.
They take Twitter questions as well, so you've got a better chance of being seen with NASA than the likes of Scott Manley or Everyday Astronaut.
Right. Pulsar Wind Nebula measure magnetic polar photo electron pixel capture photography. Did you just put a bunch of words together? Because I don't understand this. It sounds like one of those 12-word things for your crypto wallet, that you have to type in to get access to your wallet. I don't understand that. I'm sorry, Scott. Disillusion is asking, did everybody just go to YouTube to chat? No, I'm seeing your chat. You're on Twitch. I'm seeing you there.
Everywhere.
And Official Mystery, he's also there. He's also on Twitch. Yes, this is an interesting piece of new technology. And so I'm very, surprised that I'm a little disappointed in myself that I didn't know about this, because usually I try to keep up to date on this. There's a lot of other things going on that I'm going to talk about coming up. The Euclid mission, for example, from ESA. There's also other ESA missions that I want to talk about in addition, because I think ESA is starting to really step up its remote sensing astronomy part, in addition to getting involved in manned space exploration. But ESA has really got a big role, not only in JWST with the launch and running area and space, but the other missions it's got coming up, both to Mars and to other places. So I'm going to start talking a lot more about ESA technologies as well coming up.
That looks like a very good mission.
Architufus, it's good to see you again. Let's see. SpaceX learned really fast that YouTube chat is a bottomless cesspit. They turned off chat after
Yeah.
their first stream. I guess NASA just learned about that. I know, right? I mean, YouTube barely keeps me on it, right? I just filled out a survey from YouTube where it asked me what I thought about different parts, and I told them, right? And one of them was, the comments on YouTube and the chats are just like, where do these people come from? And there's no, it's been that way since 2007, though, to be fair, since I started posting things anyway.
Yeah.
2006.
I mean,
actually.
there is a way around IP banning. They just change their IPs and
There's no way to
create
stop it.
a username.
Yeah,
They're all on VPNs all the time.
if I were on Facebook, I'd probably be. If I were big on Facebook, I'd probably could do it there as well. It's just this fact that you can, go online and be a troll, and in YouTube's case, you can do it anonymously. It just really makes it worse. I do it, but I have a lot of I mean, I don't have a big audience, so it's nice. It's easier for me. I've got more moderators on my chat than I have people actually chatting. So you guys can particularly just get rid of everybody.
Yeah, because we've gotten rid of everybody.
That's right. Yeah, and that's a good way to do it. Third Rock is see you again. NASA's Twitch stream, you have to be a follower for X days before you can chat.
Yeah.
Yeah.
Well, I've been a follower for 10, 15 years for NASA, so
yeah,
I'm all right.
Yeah, I think you could probably comment. Everywhere I've been on YouTube, comments are really friendly. Yeah, not me.
Yeah.
I'll just say that. I've had my bouts with them.
Recently there have been.
Yeah.
But when I first started, no, they weren't so friendly.
Yeah, I mean the chat not so much. I haven't had a lot of trolls on the chat, but it's when I post a video, the comments on there get real shitty. So I've gotten to the point now. I used to think back when I was naive and YouTube, back when I was just uploading once in a while. I just said, well, just let it go. I'm not going to censor anybody. And then after a while, I saw what people were writing, and I'm like, you know what, I'm going to delete this. And I just start censoring people, and then I'll ban them. And I have no problem doing that now because, some opinions just are not equal to other opinions. And so I don't feel bad. You can cry about free speech somewhere else. Yes, we are going to finally have proof if the Earth is flat. No, we already have proof. We have plenty of observations. This telescope isn't going to help, but
yeah. So this is a segue into.
I delete them, Galaxy, to answer
another topic.
Huh?
Tony. Okay, it's just this little bit here is a segue into another topic. On the sky at night, they were going through all of the previous things that they've covered this year and looking forward to next year. But it was also Christmas jumper day. So you never guess what Chris Lintott was wearing.
Christmas jumper.
Yes.
Yes.
A Star Trek The Next Generation Christmas jumper.
Ah, okay.
And he was beamed up at the end.
Well, good.
Yeah.
Did you see?
Talking about Star Trek?
Oh, go ahead.
The Alcubierre team, they've managed to theorize a working warp bubble.
Yeah, are you sure about that?
Yeah, in theory.
Yeah.
Which is progress.
Uh-huh. They put
It
together.
can be done. There, that's where I put it. I'll stick it into live chat as well.
Okay. Yeah, well, you have to understand that I'm pretty skeptical about that, right?
Yeah.
So
DARPA researchers find it in Strange Encounter. There we go.
All right.
Dr. Harold G. Sonny White, if you know of him, of the Limitless Space Institute team. Let's see, there we go. So if you want to have a read of that,
all right, let me see what you've got here. All right, world's first warp bubble discovered by serendipity. DARPA researchers find it in strange encounter. The world's first warp bubble emerged as a recent accidental discovery by DARPA-funded researchers, according to the latest report. The Limitless Space Institute team found, led by former NASA warp drive expert. Is this real? Harold G. Sonny White has spotted an interesting encounter that could be used by the spacecraft for faster travels. The world's first warp bubble emerged as a recent accidental discovery by DARPA-funded researchers, according to the latest report. In an interview with The Debrief earlier this week, White said that their serendipitous encounter with the warp bubble is not about it being a bubble analog. The specialist said that it was a real and tiny creation of its kind, making this accidental vision a significant breakthrough. Initially, we knew that Miguel, a Mexican mathematician, tackled the warp drive through his mathematical calculation in 1994. He proposed that the science fiction-like discovery could allow space vehicles to traverse the universe without violating any physical laws. Since then, many scientists have shared their thoughts about warp drive. Some of them knew that it was impossible to devise some proposals. Back in September, Tech Times reported that NASA wrote its explanation about the whatever drive. According to the space agency, the warp drive borrows the two concepts from the famed general relativity by Einstein. Even though this guy said it was possible, White said that they would be needing to lessen the energy requirements and materials from the original creation. This potentially gives the experts a ghost of a chance about its occurrence. Seemingly, it resembles what we usually see in Star Trek movies, but this real-world warp drive could also not require the reduction of exotic matter, according to some physicists. Okay, this is weird. Discovering warp bubbles by chance. In a similar report, DARPA-funded researchers jump into a more feasible approach from sticking to theoretical concepts. Per White, his team believes that there is a way to achieve this goal. The latest findings in the European Physics Journal, the DARPA project appears to be closer to the set Alcubierre, I'm saying it wrong, metric to attain the creation of a warp drive. It was mentioned there that the negative energy density. Moving forward, White and his team look forward to designing a testable warp drive craft in the next tests. How does it work? In a report by The Conversation, the warp drive works by making a space-time around the spaceship. It would curve the latter to lessen the distances between them. From the creation of negative energy, and imbalance between the particles could take place. The mass could trap the particle, while the other one would be the negative energy in the space-time bubble. However, there's another statement. Why light speed travel is bad, per Tech Times report. First, the spacecraft could not cope with the speed, which would result in its destruction. The second reason why it's bad is because of the time dilation, which means that time slows down when you move faster. Let me see what NASA says about this.
The slowing down of time.
Okay, here's a whole article on the explanation of it.
Theorized. Yeah.
Is warp drive, is it even real, and where did it come from? Yes, it's real. It's just the science behind the theoretical performance is so mind-boggling you'd swear it came from an overactive imagination of a Hollywood writer. According to The Conversation, this is twice they've referenced this. Let me go to The Conversation instead of reading this. New warp drive research dashes faster than light travel dreams, but reveals stranger possibilities. Okay. I don't have time to read this right now. Okay, so I guess the takeaway is some people are saying this is possible, but that it's not likely anytime soon. It warps space-time around the spaceship and causing it to go places faster. The math is very complex.
So this is better than...
let me just read this. Imagine a rug with a cup on it. You're the rug and you want to get to the cup. You could move across the rug or tug the rug toward you. The warp drive is like tugging on space-time to bring your destinations closer. But analogies have their limits. A warp drive doesn't really drag your destination towards you. It contracts space-time to make your path shorter. There's just less rug between you and the cup when you switch the drive on.
Yeah, it pulled space. So get a bit of paper and stick a pen through it, and that's warp drive, because the quickest way from A to B is straight across. But with the warp drive, you fold it and then you stick a pen through it, and you make a hole, which is the warp bubble.
Well, this is saying you're bending it so that you're bringing it towards you, and
Yeah.
that is
Yeah, it's several waves is better
okay. So it
analogy
uses
for warp drive. For the Event Horizon engine, the black hole drive, they bring one point in space towards another point in space and create a wormhole and go through there. It's same as I'm not sure how hyperspace works. I think it's folding space as well, but it depends on the type of engine for hyperspace. So technically, it can be. Theoretically, hyperspace is faster than warp drive, but not as fast as the black hole wormhole drive. If you see what I mean, taking
sure. I'm just listening to you going hyperspace
Hollywood
is
analogies,
better than warp drive. I mean, this is
taking
silly.
Hollywood analogies, of course,
Right,
because
yeah.
there was only one
So
theorized
yeah,
in
can you do
real
the
world.
Kessler run in how many parsecs? Right. So I guess in that line always sounded stupid in Star Wars, right? He can do the Kessler run in so many parsecs, and I was thought,
But
how can
it's
you do a
because
run
of
in distance? But apparently here's what you do:
yeah.
you would shrink the distance in such a way that
No,
it's
no.
easier to do.
The Kessel Run is actually a
Oh,
run where it's
you thought
really
about this?
hazardous. So it's got gravity wells, it's got things flying about very close
All right,
to each other.
I'll defer to
You
you
know,
on that.
like the center of a galaxy.
Sure. Okay.
Across the center of a galaxy in so many parsecs.
Mm-hmm.
So you've got to skirt about. So it's it's not to do with the size of the area. I don't
Okay, well,
think.
I was trying to make a connection, but I
Yeah,
guess I stand corrected. So
it was
John Shuffle
explained in the
John is
film
correcting you, by
Solo.
the way, Peter. He's saying that folding a sheet of paper and sticking a pencil through it isn't warp drive; it's a wormhole.
No, yeah,
So,
yeah, that's what Event Horizon uses.
huh? The, what the Event Horizon uses? What?
A black hole wormhole drive.
Oh, is that
The
another?
black hole powers the engine to create the wormhole,
Okay,
and it takes them somewhere else.
I have no idea what you're talking about, Peter. What are you? What's
Oh,
it?
you've never seen Event Horizon?
No, is that a movie?
Oh, you'll have to watch it. It's very good.
Uh,
It's a rescue operation.
oh, okay. I'll have to check it. I've never even heard of it, and I consider myself a pretty good science fiction guy.
It's Laurie Fishburne, or Sam Neill.
Oh, I saw the preview for that.
Yeah,
Yeah, it didn't interest me.
yeah. Oh, you have to. It's
I don't know, man.
really good.
I saw that. I was like, no, I'm not watching that. M. Ditmar saw the guy's presentation on the warp bubble. It's theoretical based on the Casimir effect, no actual experimental results. Well, they made it sound like they created this thing accidentally. I mean, is it misleading?
Yeah,
Oh, no. Tell me I just read something misleading. Yeah, something
no,
about this isn't sitting with me, but I don't have time to dig into it right now. And he is
yeah.
saying that it is misleading.
Maybe for your next stream,
Yes. Well,
you could
shocker,
debunk it.
shocker that this thing is. I've been misled by a press release. So it's already read that. Press the
So
right.
the guys from the Limitless Space must have had a proofread by the DARPA people.
Yeah, I don't know.
It sounds
Peter,
like
Peter, you just need to
that's
be
what's
you need to
happened.
be skeptical of this, okay? I'm going to tell you
Yeah.
now. This has a little bit of hyperbole in it, I think, but
I know,
for
but
now,
it
let's just
certainly looks
say,
more promising than it did.
well, yeah, I'm not saying a lot of things are technically or theoretically possible,
Yeah.
but are they physically possible?
Yep.
That's the thing. And of course, I guess the most big example I can come up in that regard was the Higgs boson, right? For a long time, it was theoretically possible to observe it, and then finally, it has been for a brief moment. So it can be done. I'm not saying it can't. And this idea of warping space to suit your needs is, I'm not saying impossible. Certainly, space is warpable.
Yeah.
It's warped all the time. We know that from Einstein, but whether we can control that warp, and what happens if you go through somebody else's warp while you're warping, do you end up going anywhere reasonable?
Or
And
can
there's a
we
lot of
surf
questions.
these warps?
And Dan wants to know about running into particles at that speed. At what speed? Speed of light? Because
well,
it won't be fun.
don't certain particles go at the speed of light? Neutrinos?
I think you're talking about if you're going at that speed, then you're hitting particles relative to that aren't going that fast. Then yeah, you got problems. The best book I've read on this is a science fiction book. I can't recommend it enough. It's called Aurora by Kim Stanley Robinson. It's a really, 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 really good book on intergenerational space travel and what the problems are in getting between one star and another. They were just trying to travel to Tau Ceti, and I highly recommend that book. It was one of the most enjoyable books I've read ever. It's one of my all-time favorites. So please read that book, and there's an explanation of some of this, of these problems at going relativistic speeds. And there we're only going, I think, 10% the speed of light in that example, if I'm not mistaken. So read that book. Archituvus wants to know if this is April 1st. I know, man. I initially I'm like, but Peter, I trust you, Peter.
Sure now.
Huh?
You're not so sure now if
yeah.
Well, possibly skeptical. You're less skeptical.
Okay. Apparently Anton has explained this for us. So
that's Raj. Tachyons can travel at the speed of light.
Yeah, but I think his question was more about the spaceship going that fast relative to other particles, not the particles themselves going that fast. Yes, lots of particles go relativistic speeds. That's very true. So Anton explains it. So I need to go watch Anton. He apparently does it, and Raj is concurring.
Oh yes, so I noticed that upload.
Raj says
added it to my list.
Been settled. Yeah, I did. I hadn't heard about it.
Long at the moment.
Okay, so I think I'm done. I think we have streamed this stream.
Ooh.
Stream a stream for me. And be back on Tuesday. Thank you guys for your patience in my getting here. Or my being gone last week. I will be back starting next Tuesday. We will do our therapy stream. So get ready. I have exercises for you to plan on to get yourself centered for that most stressful launch tomorrow or the following day on Wednesday.
AWXT, it's next week, isn't it? Next Wednesday. That's when the NASA hangout is planned.
Right.
Yeah.
Did you listen to anything I said at the top of this?
Oh.
I said it's good. Tomorrow. I even showed it to you. Here is where their stream is going to be, Peter. Look at the stream. Watch. So I'm putting it up. Look. This is where they're going to be streaming from NASA, the launch next week, 22nd. I'm gonna show this while I'm talking concurrently. So yes.
Okay.
Did you remember? Do you remember I said that? No. You're like, no.
I'm looking at the screen and I'm thinking,
all right.
What are you talking
NASA
about?
will be streaming on Wednesday.
Yeah.
right? At the launch. This is the link. I will show that link, but you can go to it yourself. You're welcome. You know, you can go. Like I said,
Yeah.
you'll probably have 5 tabs open, right? Of all these different streams, people streaming, talking about this, of which I hope I am one. And we'll talk about this launch
No,
together.
I keep it to a minimum number of tabs,
Well,
which
okay.
is probably one for video.
Okay. All right, guys. John, Raj, Galaxia, all you guys, Architufus, it's good to be back with you guys. Peter, thanks for joining me on this, and I will see you guys next week for the week of JWST. Fingers crossed, everybody. Thank you all so much for watching, and as always, keep looking up.
Keep looking up.